All right, so hopefully everyone can see my screen. Nice to meet you all today. My name's Jason Mays. I am the developer advocate for TensorFlow.js here at Google. And today I'm going to be talking to you about machine learning in the browser and beyond in JavaScript, essentially. And before I get started, I just want to give a quick overview about my background. I'm actually from the web engineering background. And you might be wondering, why isn't web engineer here at a machine learning kind of session? And essentially, over the years, I ended up working my way combining JavaScript with machine learning, and that is why I'm here to talk to you about that today. If there's one thing you take away from this slide, I spent 16 years playing with JavaScript. And for that reason, I've got a few things to say about that in terms of why it's actually interesting to consider for a use case in machine learning. And on that subject, the first thing to talk about is that we can actually use JavaScript to run in pretty much any location. JavaScript can run in the browser, on the server side, desktop, mobile, and even Internet of Things. And if we dive into each one of those areas, you can see many of the technologies you might be familiar with already. All the popular web browsers there on the left-hand side. We've got Node.js for server side, React Native for native applications on mobile, Electron for desktop native applications, and even Raspberry Pi via Node.js over there for Internet of Things. And JavaScript is like the only language that can run in all of these environments without additional add-ons and plugins and all this kind of stuff. So for that reason alone, it's very powerful. However, with TensorFlow.js, you can retrain by transfer learning, or you can write your own machine learning models completely from scratch if you so desire, just like you can do currently in Python. And of course, that means you can dream up anything you may wish, from augmented reality, sound recognition, sentiment analysis, and much, much more, which we'll see of today. Now, the first way you can use TensorFlow.js is three different ways, depending on your background and experience with both machine learning and JavaScript. The first one I want to talk about are the pre-trained models. These are really easy to use JavaScript classes that, even if you have very limited knowledge of machine learning, you can actually use these very quickly and effectively. And we've got many of these that are available to use out of the box, fully open sourced, such as object detection, body segmentation, pose estimation, and all the other things you may be familiar with here. Even BERT has been converted to run in the browser, and that's pretty cool. So let's dive into some of these models and how we can actually code them to use them in the web browser and beyond. So the first thing we're going to look at is object recognition. This is actually using Cocoa SSD behind the scenes and has been pre-trained on 90 object classes. As you can see, I've made a little demo here on the right that allows me to get the bounding box information back and render it to the browser to highlight the objects in the scene. And we display the class and the confidence values there as shown. So let's walk through the code on how I created this so we can see how this is actually put together. So first up, we've got the HTML. Nothing too fancy here, just bread and butter HTML. First thing we're going to do is import some style sheets. Second, we're going to have a section for our demos. And initially, this is going to be invisible because we want to wait for the machine learning model to load. And then when the machine learning model is ready, we'll then make the demos visible so you can then click on them and interact with them. Now, within this section, we're going to have a bunch of images that you can click on. And when you click on them, you're going to get the results for the object in that image. And these are contained within a div element so that we can actually render other things to that area later on, as you'll see. And then all we need to do is import some JavaScript libraries. The first one is TensorFlow.js itself. The second one is the Cocoa SSD model that we want to use, which is one of our pre-made models that I just spoke about. And then the third thing is the script, the actual JavaScript we're going to write to use both of these things. So that's all you need for the HTML. So let's dive into the JavaScript, the script.js on this page. So the first thing we're going to do is we're going to grab a reference to the demo section in that HTML, and that's simply using getElementById, so bread and butter DOM manipulation. And we're then going to have a global variable called model, which is just going to be undefined for the time being until we've loaded. So the next thing we need to do, of course, is load the model. Now, because we imported Cocoa SSD with our script tag on the previous slides, this Cocoa SSD variable will now be available to us. And we simply call Cocoa SSD.load. And because this is an asynchronous operation, we use the then keyword. So when it's ready, it will then call a function of our choosing and pass us the loaded model. This loaded model we can now assign to our global variable model, so we know that the model is loaded and we can use it in our other code. And we can then remove this invisible class in the CSS such that the demos now render correctly. So you'll see in the demo later on, it goes from a grayed out state into a nice colorful state, so you can actually know when to click on things. Next, we're going to get all the images that we want to be clickable. And of course, I gave them a class of classify on click in the HTML. So I'm just going to grab all the elements that have that class. So we're going to get an array of images here called image containers. And we're going to iterate through all of those image containers. And essentially, we're going to get the child image node and add an event listener for a click event and associate a function called handle click when that element is clicked. So if we go into the handle click function, you can see all this does here is when it executes, an event is passed. And if the model has not already loaded, because it does take a couple of seconds, then we're just going to return straight away, just in case someone tried to click on something before we are ready. Otherwise, we're going to go ahead and call the model.detect function. And this, of course, takes an image-like object as its parameter. In this case, we're passing the event target, which is the image that was clicked. And again, this is an asynchronous operation, so we wait for that to finish, and then it will pass the predictions to a function of our choosing. In this case, I've named it handle predictions. So let's dive into the handle predictions function. And essentially, you can see here, we just get a JSON object passed back, which you can just console.log if you wanted to see what it looks like. But essentially, it's just an array of objects for things that we think we found in the image, along with their confidence values and so on and so forth. And essentially, we can then iterate through those objects as such using a for loop. And we can start creating some new HTML elements so that we can start rendering out the details to the screen. So all I'm doing here is I'm creating a paragraph tag, and I'm setting the text of this paragraph tag to contain the class and the rounded score for the accuracy, essentially. I then simply add some style to this paragraph so it appears at the bottom left of the image. And then I simply add a div element so I can actually have a bounding box. And this div element is just going to be lots of dashed lines so we can have the bounding box showing nicely. And I'm just going to put this at the position at which the ML classification recognized the object. So I'm just setting the width, height, top, and left. And with that, we've got a bounding box. So all I need to do now is add these two elements I've created in memory to the actual DOM, the actual the web page itself, and we're basically good to go. So finally, there's some CSS. This is up to you how you want to style things, of course. But here I've got some nice transitions, and I've got some like borders that are dashed and so on and so forth, just to make it look pretty. And if we go over to the live demo, you can see what this is going to look like. So I'm going to stop sharing this screen and go over to my other window. One moment. Share screen again. And hopefully I can now find my other tab. Here we go. Good stuff. So now we can see, essentially, if we switch to my new window, I think I still see myself. Perfect. Yeah. You can see here that this is the demo running live in my browser right now. And if I click on any of these images, you can see we get the instant classification of the objects it can detect in the scene. And notice here, even though we've got multiple objects, they all come back nicely, and the objects are different types and so on and so forth. So now you can see how you could use this very easily to detect if your dog at home is trying to eat your treats or something like this. It would not be too hard to take something like this and turn it into a smart cam. Now, what's even better here is that if I enable my actual webcam right now, you can see me in my bedroom talking to you all, and we can do this with webcam imagery as well. So if we just call the predict function many times per second, we can actually get a live update of everything, as you see here. And notice how fast this actually is as well. This is running in JavaScript in the web browser and at very high frames per second. So JavaScript is very, very good at the display of information and computer graphics and all this kind of stuff. And that's basically what it's been designed for. So it's very easy to make these visual kind of feedback systems, as you see here. So I'm now going to stop presenting this and go back to the slides. One moment. Share screen again. And boom, there we go. Back to the slides. If you can present my slides again for me. So next up, we have face mesh. This is just 3 megabytes in size. And essentially, it allows you to recognize 468 facial landmarks. So this is just another pre-made model like the one you saw before, but this one is aimed around identifying parts of the face. And you can see here, this can be used for many interesting things, including augmented reality, such as the image on the right-hand side there. This is actually by Modiface, which is part of the L'Oreal group. And this lady on the right is actually not wearing any lipstick. We're actually using face mesh to understand where her lips are, and then using WebGL shaders to then overlay 3D graphics on her face, so it looks like it's actually on her face and looking very realistic. And she can change the shades of a lipstick and so on and so forth. And this is really great in today's world where everyone's stuck at home, they can't go touch the products, and maybe you don't want to try on products that other people have touched. So in that case, this is very useful and can help you still shop in these times. And I just want to flip to the demo for this as well to show you it running live, because it is really cool. So if I just go ahead and swap my screens again, there's going to be a bit of screen swapping going on today. One moment, share this. So now you can see that I'm actually doing this live in the web browser. And if you can present my screen again, whoever's moderating. Can someone present my screen? Thank you, perfect. So here you can see my face is being detected in real time on the left-hand side here. So the machine learning is going on the left. But because this is JavaScript, there's very rich libraries for 3D graphics, as I mentioned before. So on the right-hand side here, you can see I'm rendering a 3D point cloud of my face in real time at the same time as doing all the machine learning, all in real time in the browser. And you can see here, I'm getting like 25 frames per second, even though I'm live streaming to you right now, which is using up my processor quite a bit. But this is running on the CPU. You can see at the top here, this is running in WebAssembly, WASM, and that means it's executing on the CPU of the device in the web browser. I can actually switch this to WebGL, and then I could actually get even faster performance by leveraging the graphics card of the device. And if I do that when I'm not streaming, I can get like 45, 50 frames per second for this particular model, which is pretty cool. So things run really fast, it's super lightweight, and allows you to do whatever you might want to dream up. So I encourage people to kind of get creative with these models and figure out how they might want to apply them for their use cases. Okay, so I'm going to stop this and go back to the slides again in one moment, sharing my screen. Boom, okay, back to the slides. So here, next up we have body segmentation. This allows you to distinguish 24 body areas across multiple bodies in real time. This is called our body pics model. And you can see here on the right-hand side how this works in action. And you can see like multiple bodies being detected at the same time, and all the different colors represent different parts of the body. And even better, we can get an estimate of the pose as well. But that's the blue lines you see in the image on the right-hand side. Now, with a bit of creativity, we can actually emulate many of the superpowers we've been promised in the movies by now. And I just want to share a few examples that I've created to illustrate this. The first one is Invisibility. This is running live in the web browser, and I made this in just one day. And I'm able to remove myself in real time from the webcam in the browser. But notice as I get on the bed, how the bed still deforms. So it's not some cheap trick where I'm just replacing the background with a static image. This background is being updated in real time, and I'm only removing the body pixels, and I'm calculating what the background is over time. So this can lead to some cool effects. But what about lasers? We can, once again, if you're talking about WebGL, we can have people from our community making things like this, which allows him to use WebGL shaders to understand how to combine this with face mesh to shoot lasers from his mouth and eyes, just like you can in Iron Man or something like this. And I thought, well, this is pretty cool, but let's go one step further. And some of you may have seen recently on social media, I created this kind of teleportation demo that allows me to segment myself in real time. I then transmit myself using WebRTC, web real-time communication, over the internet to some remote location, and then using WebXR, which is web mixed reality, essentially, I can then place myself in a remote room, and the person who's watching me in that remote room can walk up to me, they can hear me from the right angle, and they can move around me, and so on and so forth. So now, instead of having a video conference where you're stuck in a rectangular box, you can actually be physically present almost in 3D, and it adds to the immersive feeling and more personal feeling of meeting someone, especially in the times when we're stuck at home and it's very hard to be out in large groups and so on and so forth. And of course, other delightful creations can be made beyond this as well. And here's another one I created for clothing size estimation. I don't know about you, but I'm terrible at knowing what clothing size I am out in the wild. I always forget my sizes. And of course, body shape changes over time as well. So here, in under 15 seconds, I can use body pics to figure out what my size is, giving my measurements for chest and height. So no, not the height. Using my height, I can figure out my chest and my inner leg and waist and those measurements, which allows me to then select automatically on the web page if I'm a small, medium, or large, that kind of stuff. So now I can buy stuff without having to return it all the time and save time and money because of that. And of course, we've seen the community also do some great things too. And this guy from Paris in France, from our community, has managed to combine it also with WebXR and WebGL so that he can scan any magazine and bring that person from the magazine into his living room. So maybe you're interested in fashion or something like this, and you can now go and inspect those clothings in more detail in a way that is more meaningful to you. And notice he's using his mobile phone here. He's actually using a 2.5-year-old Android device to do this. So it doesn't require the latest hardware to do this, but it's all running in the web browser on that device, which is pretty cool. Now, the second way you might want to use JavaScript-based machine learning is transfer learning. Once you outgrow our pre-made models, maybe they don't quite work with the data that you have available to you, you might want to retrain those models to work with data that's more meaningful to you. And of course, if you are a machine learning expert, which I'm sure many of you are given the audience today, you can do the same stuff you do in Python, then you can do this all by code if you wish. However, today I want to focus on two examples that allow you to do it much faster than that for more simpler use cases. And the first one, of course, is Teachable Machine. Now, this is great for prototyping because it allows you to do everything in the web browser. At no point other than delivering the web page is a server used. We're going to do the training in the web browser, and we're going to do the inference in the web browser. So the best way to explain this is to go and use it. So let's switch my screen and show you how this works. So once again, I'm going to stop my presentation here and flip over to Teachable Machine. Boom, there we go. So when you go to teachablemachine.withgoogle.com, you are presented with a page something like this. Right now, Teachable Machine can allow you to train to recognize images, audio, or specific poses. And these three are just the starting points. I'm sure more will be coming soon, as it says here. But for today, we're going to go with image. So you click on image, and by default, you have two classes, but you can add more classes if you like at the bottom left here. Now I'm going to go ahead and name these so they're more meaningful. So the first thing I'm going to recognize is myself. And the second thing I'm going to recognize is a deck of playing cards that I've got in my room right now. So all we need to do is click on webcam and allow access to a webcam, and you get a live preview of what's coming from the camera here. And we can use this to take samples of the object you're interested in. So I'm just going to sit here and move my head around and get a few samples. So one moment. There we go. Maybe a few more. There we go, cool. So we've got like 38 images of my face in various positions. And of course, if you're doing this more properly, you would do this with more variety and have more training data. But for the purpose of today's demo, that's all we need. And then for class 2, we're going to do exactly the same thing. So I'm going to hold up this deck of cards instead. So I'm going to get roughly the same number of images, so about 38. Okay, 41, that's close enough. And then I'm simply going to click Train Model. Now, what's going to happen here is that the TensorFlow.js is going to retrain the top layer of this model that Teachable Machine is using, which is actually a KNN classifier built upon MobileNet. And we can then repurpose the other understandings that MobileNet has already learned to then classify these objects here. And you can see in under 15 seconds, it's already trained, we're done. And we can see on the right-hand side here a live preview of it in action. And you can see here that it predicts the output as JSON, which is correct. That is currently what's showing on the live preview. And if I hold up my deck of cards, you can see it goes to cards straight away. JSON, cards, JSON, cards. And look how fast that was. In under 2 minutes, we've managed to make something that you could use for a prototype to demonstrate something, and you're good to go. So if this is good enough for your needs, you can simply click on Export Model here. You can click on Download, and you can download the various files that are containing the model weights and such. And you can host those on your web server or CDN, and then use that on any website you like using the code below. So really not too hard at all. And of course, if you're trying to make more robust models, you would need more training data to avoid any biases and so on and so forth. And for that, as already mentioned, Google Cloud AutoML is super for those kinds of situations. So if I stop presenting this and go back to the slides, share screen. Boom. So the next thing is Cloud AutoML. And of course, the previous presenter has already gone in this in much detail. So I'm just going to give a very high-level overview here. But essentially, as already mentioned, Cloud AutoML allows you to train custom models in the cloud. However, it can export to TensorFlow.js, which is pretty nice too. That's why I just like to touch on this very quickly. You can see here how someone's trying to recognize different flowers. They just uploaded all their folders of flowers to cloud storage, and then you can import that via Cloud AutoML, as you saw before. You then set your various options if you want to have a higher accuracy or faster predictions, and set your various hyperparameters if you want to. And then you click on continue and wait for it to train, as you just saw. You then have an option to download for TensorFlow.js at the end there. You download that zipped bundle and you unzip it onto your server and store it somewhere on a CDN. And basically, you can then use those files on your own website. And you might be wondering, well, how hard is it to use TensorFlow.js trained from Cloud AutoML? In fact, it's so easy. It fits on just one slide, even easier than the demo I showed you before. And let me just quickly walk you through this. All we need to do is import two libraries at the top in HTML. So this is just the TensorFlow.js library and the Cloud AutoML library. The third line here is just a new image that I want to classify. This is just an image of a daisy that I grabbed from the internet. This could be anything. This could be the webcam. This could be something else if you wanted to. But for today's demonstration, I'm just going to use this image here. And then this is the actual JavaScript, just 3 lines of code. All we need to do is await for the model to load. So tf.automl.load image classification. And this is just past the model.json file that you would have downloaded from the previous step and hosted on your website somewhere. So you just tell it where that is, and you await for that to load. And you use the await keyword because this is asynchronous. It takes some time to do so. And when it's ready, it'll then be assigned to this model constant on the left here. We then grab a reference to our daisy image, which is just above. I'm just doing a get element by ID, and you can see I've got the ID of daisy up here. And now that's stored as constant image. And then all we need to do is call model.classify with the image we want to classify and await the results to come back. And again, this is an asynchronous operation, so this might take a couple of milliseconds. And then you get the predictions as a JSON object, which you can then iterate through just like before and print out or do something useful. So super easy to use, but this can be used for production level quality applications because you can upload gigabytes of data to Cloud AutoML, and the models there are very robust for the purposes of image classification and much, much more. And then the third way to use TensorFlow.js, of course, is to write your own code completely from scratch. And for those of you who are used to doing that, I'm not going to go into that right now because that's beyond a 40-minute talk. However, I'm going to concentrate on the superpowers and performance benefits you can get by considering using JavaScript over maybe Python or something like this. And essentially, to understand this better, we need to talk about how TensorFlow.js is actually being architected. Essentially, we have 2 APIs. The first one is a high-level API called the layers API. This is basically similar to Keras if you're familiar with Python. And in fact, if you've used Keras in the past, you'll be very familiar with our layers API. We even have the same function definitions and so on and so forth. The only difference is that you're using JavaScript over Python, but the function calls will be pretty much the same. Down below, we have the ops API, which is the more mathematical API that allows you to do all the linear algebra and that kind of fun stuff. So if you do want to get down and dirty of the code on the lower level to make your own models or new things from scratch, you can do that with our ops API as well, just like the original TensorFlow. So bringing this all together, you can see how our pre-made models at the top there are sitting on top of the layers API. The layers API sits on top of the core or ops API, depending what you want to call it. And this can then talk to different environments, such as the client side. Now, on the client side, I'm referring to things like the web browser, WeChat, React Native, those kinds of environments. And each one of those environments understands how to talk to different backends. And by backends, I simply mean hardware device. So the CPU, the processor, WebGL allows you to run on the graphics card in JavaScript in the web browser. And WASM, or WebAssembly, is how we get better performance on the CPU. So depending what's available to you, depending what device you're running on, you can choose which one of these you want to execute on. However, CPU will always be there, but it's the slowest form of execution. And you probably want to be using WebGL or WASM for real-world usage. And most devices actually support this. I think WASM has over 95% support across devices, and WebGL is like 86 or something like this. So very widespread support. And that can run on an NVIDIA graphics card or an AMD graphics card. So that's already pretty cool that you can run on many more devices. Now, the flip side of this story is that we've got the Node.js story, and this is for server-side stuff. Just like you would be doing Python already in the server side, Node.js is our equivalent for that in JavaScript land. And the Node.js actually talks to the same TF CPU and TF GPU backend that's written, I believe, in C++ or something like this. And that means it has the same performance as Python for model inference because we can also leverage the same CUDA acceleration and AVX support and so on and so forth behind the scenes as both Python and JavaScript are basically talking to the same backend, which is written in C++. So with that, if you are doing all your ML development in Python, there are some ways you can have a more easier journey to the web via Node. So you can actually take a Keras model that you've saved and load it via our layers API in Node.js if you want to take something from Python land. Or the equivalent on the lower level is to take the TensorFlow saved model, and you also load that in Node.js without any conversion and use it on the server-side environment in Node.js for free. And there's some advantage to doing that, as we'll see in just a second. Now, the third thing you might want to do is convert a TensorFlow saved model from Python and use it in the web browser. Maybe you want to reach more people and get more people to try it out or something like this. As a researcher, that could be useful to you. With the TFJS converter, you can basically do that. And there are some caveats with that. We don't have all the opt support that TensorFlow Core has right now. Obviously, we're playing catch up. We're a newer team. We're only 2 or 3 years old. TensorFlow Core has been around for much longer. So we are open source, and we welcome contributions to those opt supports if you want to add more ops on the TensorFlow.js side as well. But honestly, a lot of models do convert without any issues. It's only if you're using some more exotic operators that you'll find that is an issue. And of course, it will mention which operation is not supported, and you can either choose to implement that or use a different opt to get around that. Cool. So let's talk about performance then. This is for MobileNet v2, and you can see that running on the graphics card in Python, it takes 7.98 milliseconds, and running on a graphics card in Node.js is 8.81. So it's within the margin of error pretty much, depending which way the wind was blowing on the server on the day that we recorded this result, and it's pretty much the same. But the real beauty comes when you're doing a lot of pre and post processing. Now, often, as you're probably aware, in machine learning, you have to manipulate the data coming from sensors or so on and so forth to get it into a format that the machine learning model can digest. And this can be very non-trivial at times. So in JavaScript, if you do the pre and post processing in Node.js, you can benefit from the just-in-time compiler that JavaScript has, because we compile at runtime. And that can actually lead to a 2 times performance boost. As you can see here, for Hugging Face, the Dilbert model, they converted to use Node.js. And whilst the inference was the same, the whole pipeline was 2 times faster because of that pre and post processing having been converted to Node.js as well. So, go play with some things. I do encourage maybe doing your models in Python as you're used to, but go play with it, putting it in Node.js for the pre and post processing. And then not only do you get the reach and scale of the web, but you also get some of these performance boosts for free as well. So it could be a nice marriage of technologies right there. So let's talk about some of those superpowers then. If we just focus on the client side for a second, so this is TensorFlow.js in the web browser, then we get the following kind of very useful benefits that are hard or impossible to achieve in a server-side environment. Now, the first one is privacy. If you're executing entirely in the web browser, that means any data coming from the sensors stays on the client's machine. At no point is the imagery or sound or whatever other data you're grabbing is never sent to a third-party server. And in today's world where privacy is top of mind, that's really important, especially if you're making some kind of healthcare application, as we saw before, or even something legal requirements. Maybe you're in Europe with GDPR rules and this kind of stuff. There's many reasons you want to execute things on the client side. Now, if you're executing on the client side, that leads to point number 2, lower latency. Because there's no round trip time to the server and back again, especially on mobile devices, the latency involved there could be quite high. You could be looking at 100 milliseconds or more just to talk to the server and get a result. That means you can have higher frames per second if you're classifying stuff in real time directly at the source where the sensors are, and the web browser has direct access to all of those sensors. Third point, lower cost. If you're not running a server, then of course you don't need to keep a server running all the time to do the inference, which means no hiring of beefy GPUs and CPUs and lots of RAM running 24/7. And if you're having tens of thousands of users per month, that can lead to some serious cost savings, maybe tens of thousands of dollars per month if you have a popular site. Fourth point, interactivity. As I mentioned before, JavaScript has been from day one all about being the kind of sharing of information and graphics and all this kind of stuff. And it's only got better since then. So we have very mature libraries for 3D graphics, charting, data visualization. And I encourage you to check some of those libraries out, as they're much easier to use than other things I've tried in other languages. And then fifth point, reach and scale. Anyone in the world can click on a web link and get access to the web page. That means you get the machine learning for free. It just works out of the box. Now, the same is not true if you're trying to do this over on the server side in TensorFlow Python or something, because first of all, you need to install Linux. Secondly, you need to go install TensorFlow. Then you have to install the CUDA drivers, which is often quite tricky to do. Then you have to go and clone the GitHub repository. And then you have to read the README of the GitHub repository to understand how to use the code. And if all of that works out well for you, then maybe, just maybe, you'll be able to use that and get it running. So as you can see, it's a much higher barrier to entry going down the other path, as an end user at least. So this, if you're a researcher, could give you many more eyes on your cutting edge research. If you can provide your model to be executed in the browser, you can maybe have tens of thousands of people using your model to give you feedback and find any bugs or biases, which you can then fix faster than if just a few people from your team are only the ones using it. And of course, on that note of reach and scale, we mentioned on the GPU, we can support 84% of devices via WebGL. And that means we can run on a MacBook Pro with an AMD graphics card. And I believe TensorFlow on the server side can only support NVIDIA, to the best of my knowledge, using the CUDA drivers. So we don't care what graphics card you have. As long as it can run WebGL, we're good to go. So the flip side of this is that on the server side, there's also some benefits here. This applies both to Node.js and Python, whichever one you're using here. So here you can see that you can use the TensorFlow save model without conversion. And this is great if you're trying to integrate with a web team, as I mentioned before. A lot of web developers out there probably are more familiar with Node.js. And if you're working in Python for machine learning, this is a really nice way to collaborate with other teams. Second point, you can run larger models than on the client side. Often you'll be limited by the graphics memory of the client's device as to what size model you can load and execute on that device. Now, in most cases, it's not too much of a problem because many of the models are just megabytes in size. But if you were trying to push down a larger model down the pipeline, then it's probably better to run it on the client side, on the server side. And in that case, you can do that using Node.js. Third point, it allows you to code in one language. Now, if you're already using JavaScript, and currently 67% of developers out there use JavaScript as their kind of production language, according to the Stack Overflow survey of 2020, then that means you need to hire less people and you can reuse your code and so on and so forth. So just make maintainability just a little bit easier. And then the fourth point, Node has a very large NPM ecosystem. So just like the JavaScript on the client side, there's many libraries you can now use for doing many different things. And then the fifth point we touched on already is the performance. You get the just-in-time compiler boost that you don't get in other languages, which means you can get up to a 2x performance boost for your machine learning models for the pre and post-processing. So with that, I'm going to end with some resources. If there's one slide you want to bookmark or screen grab today and share with your friends, is this one here. Essentially, first up, we've got our website, TensorFlow.org/JS. Go there to learn all the basics about TensorFlow.js and a good introduction. Second point, our models are available on /models there. And I've just spoken about 2 or 3 models today. There's actually many, many more that we've open sourced and you can use right out of the box. And I encourage you to go play with them after the show. We are completely open source, just like the original TensorFlow. So if you are willing to contribute, check out our GitHub code. And there's much more README files there as well for more information on the various models and so on and so forth too. If you have more technical questions, we have a Google group that you can join. This is public, and our team tries to monitor this as much as possible. And then we've also got CodePen and Glitch examples that are super easy to fork and use. And what these are examples showing how to use some of our more popular pre-made models with the webcam, with images and other data. So you can just fork that and have a starting point that works. And then you can just hack it and change it to do what you need very, very quickly. If you're looking for a recommended reading, I'd recommend the Deep Learning with JavaScript book. You can see that here from Manning Productions. And if you use Made with TF.js discount code, you can actually get 30% off that book and any book, I think, on Manning, in fact. So a great code to use for Manning. And then if you're interested, please come join the community. We do have this hashtag Made with TF.js. If you search for this on Twitter or LinkedIn, you can see even more projects that people around the world are making, not just myself and my team, but people around the world just like you who are starting out with JavaScript or new to machine learning or both, and they're still able to make some really great things. So do check out for inspiration. On the note of inspiration, I just want to leave you with one more. This guy from Tokyo, Japan, has actually managed to make a hip-hop video using TensorFlow.js. And the key thing here is that he's actually just a dancer, but he's managed to leverage TensorFlow.js to do this very nicely. And my main point for saying this is that machine learning really now is for everyone. It's not just limited to the academics and researchers. We can now start to see creatives, musicians, artists, and much, much more starting to take their first steps of machine learning too. And I'm really excited to see how TensorFlow.js can be part of that picture, given how wide JavaScript is used in the community out there for many different things. And I'd love to see what you guys make as well in the future. And do share with us if you make anything. And of course, I'm available on Twitter and LinkedIn for any further questions if you don't have any right now. So thank you very much for listening, and I'll hand it back to the presenters.
Awesome. Thank you so much, Jason. That was a wonderful presentation. Lots of amazing demos. I really love that the conclusion, which is like with TensorFlow.js, we are just democratizing the machine learning or AI part of the web revolution. Like as web came in and revolutionized the whole industry as we see right now, with TensorFlow.js, we are seeing that same thing happen again.
Yeah, it's actually like a second wave right now, and people who are jumping onto the JavaScript bandwagon right now are a very exciting time to have a lot of influence as well. And I hope to see more collaboration, honestly, between the Python communities and the JavaScript ones. Like as I mentioned, we can run the saved model format in Node, and it would be lovely to see more of the academic folk exposing their work to the web environment, so people can start using it in ways they've never even dreamed of. I mean, yeah, people are doing teleportation and all these things, right? And maybe that was the initial use case for body pics, but things like this can be now made, and with a bit of creativity, new things can come to life like this. So I'm really excited to see where that can go in the future.
Yeah, that's amazing. One of the questions that we got on chat was, why would you want to choose JS versus Python and R? And I think like you covered some of those things, but if you want to go into more details.
Yeah, I don't want to force any language biases on people here. Use whatever you're familiar with, of course. But I mean, the benefits that I spoke about today, such as the ones in the browser where you can get privacy or lower latency or more cost savings, these are the main reasons you might want to consider deploying to the web. If those things are important to you and your use case, then that might be a good reason. Or maybe you're looking to get a little performance boost for the pre and post processing. Maybe Node.js is a consideration for that kind of stuff. But honestly, you can do stuff in any of these languages and use what you're familiar with. But if you are going to integrate with other teams, then maybe consider exporting the safe model and allowing it to be digested by people who might want to use JavaScript or something like this.
Yeah, of course, yeah. That is like the great way to do it. You can not only build your new models with TensorFlow.js, you can also use existing models that are built by your other team members. Yeah, awesome. Thank you so much, Jason.
Thank you very much for having me. Cheers.
Pass it on to the next presenter. Thank you.